So in today's class, let us learn about the linked list. A linked list. So here in this we are focusing on the singly linked list. A linked list, okay, it's also called as a one-way list, is a linear collection of data elements called nodes, where the linear order is given by means of pointers. That is, a node is divided into two parts. The first part contains the information of the element. The second part called the link field or the next pointer field, it contains the address of the next node. So basically, students, this linked list is a data structure. It is a linear data structure which is used for storing the data. Here we can store the any number of data in a node, and this is stored in a random fashion. Okay, so let us see how does this linked list look like, and you also understand its memory structure and its node structure in the coming slides. So this is a sample singly linked list. Okay, so this is a node. Whatever we have seen, this is a node. So a linked list is made up of many nodes. So how does we come to know where does a linked list start and where does the linked list end? So every linked list will have a pointer of type node, okay, which tells where it starts. So here we have given the name as first. Sometimes we also give the name as beginning, where it starts. So this tells this pointer tells where the linked list starts. Okay, here. So here we have two fields. Okay, so one is a data field. In a node we have two fields. One is a data field, one is a pointer field, pointer to next node, pointer to next node. And how does we come to know where does it end? Wherever we have a null, let us see, when we have a null, there the linked list ends. ends. So students, here basically now how does the addresses are stored? Okay, how does the addresses are stored? So students, here say let us randomly name some addresses here. Okay, so it's all actually it's stored randomly only. So let me give a number as 100. This may be 133. This may be 186. This may be 95. So it's stored random. I told you whichever place is available there it is stored. So this may be 83. This may be 125. This may be 180. 172. Okay, so how does it stored, students? See, now I told you the link field, okay, that is this one, okay, shows the address of the next node. Okay, so here the 133 will be stored, okay, and here 186 will be stored, here 95 will be stored. This is how it gives the track. This is how it gives the track of the next node 83, because it's not continuous in fashion. And here we can store any number of nodes. Here we can store any number of nodes. Here 172 is stored. Okay, so this is how it is stored. This is how it is stored about the singly linked list. So let us see the node structure now. So node structure, actually first has two fields. One is the data field, data or info field, information field. This is a pointer to the next node. Okay, or address field, address of next node. So students, here how do we define the structure? So for that we use a structure struct node. Okay, this is the common syntax. This is the common syntax which we use in all the programs of linked list for defining a node. Okay, so here this is char data 10. This is for defining the data field, and this is for defining the address field. That is why it is a pointer, students. Okay, so here star link, it is a pointer. Okay, it's a pointer variable because we need an address there. Okay, and this is a normal variable. Okay, with 10, with space 10. That means if we can store our data or character data which is having up to 10 character. Okay, so that is the node structure. So let us read some theory. How do we represent the linked list in a memory? How does it represent the linked list in a memory? So here they have named the list as a linked list name as a list. So then the list will be maintained in the memory as follows. So let us go through the points. So list requires two linear arrays, students. Okay, so one has info, so info, and another one is link. So here info k. Okay, so this info k, it contains the information part, and the link k, it contains the next pointer field of a node. Okay, the second point, list, it requires a variable name called as start. So why do we require this variable name called as start? Because it tracks the beginning of the list. It tracks the beginning of a list. And if a next pointer field, if it is denoted by a null, that means what? It is the end of the list. That is what we need to know. So the subscripts of the arrays info and link will be positive. So choose null is equal to 0. So this is the representation of linked list in a memory. So let us see now actually how it is stored in a memory. So okay, so students, we know that always its linked list starts from a pointer called as start. Okay, so it is starting from a address 3. Okay, so let us draw a node here for our understanding purpose. Here in 3, this is 3, and it is having a information called as back. Now where does it point to? It point to 5. So this is another node which is called as 5, and we have to go to the 5 location here, and we have a cat there, and in this pointer location we have 5, and in cat will point to 1, and in one location we have another thing called as eat data, another data called as eat, and eat will point to 2, and this 2 means in second location we have another node which is hat with the memory 6. Next we have another node here in 6, that is mat. Okay, we have another node here which is called as mat. So this mat will point to 7. So our next node will be in the address 7, which is nothing but fat. Okay, which is going to 9. So in our ninth node we have VAT, and this is the last node because it is pointing to null. it is pointing to null. So this is our linked list. Okay, it's 9 and this is pointing to null. So we have 0 here, that is pointing to null. This tells that it is the end, and this is the beginning, students, because we have start here. Now how do we access the data? Now how do we access the data? So here we know that start pointer, it will tell the beginning, and data, if you have to access, you need to do data of 3. Because why data of 3 here? Why data of 3? Because the name of the array which holds the data is known as data. That is why data of 3. By index you will access data of 3. Okay, so in data array, the index is 3. If you get that, then you will get the data. That is how you get data. And same thing applies for all others also. Okay, so if you want data of 5, okay, you get cat. Okay, so data of 1, you get eat. So also all these we are referring to the data places, that is data. Okay, yes, so that is how you get all the data here. Now how does I get the address field? For that I need to access the link field. Okay, so if I get link of 3, okay, then I get 5. If I get link of 5, I get 1. Okay, so that is how I get address. So whenever I get link of 9, because link of 9 is the last one here, see here, this is the ninth address link field. When I access the of the ninth address node, that time I get the null. So we will come to know that linked list will end there. That is how things are stored in the memory. Okay, now let me go to the next slide. Yes, so students, in the previous slide we have studied about the memory allocation. Okay, where, so that is how it is stored. Now here they are telling you one more concept about the garbage collection. This tells you, students, wherever free spaces are available, that space, this avail list will take care. Okay, so here avail list will start from 10, so that is a first address. Then after that it will point to 2, so 2 is also empty. Now next, okay, which will point to 6. Okay, 2 is also empty. Next it will point to 6. Next it will point to 0. That means what, student? This two spaces 10 to 6 are free. Here whenever we delete a node, spaces we are available, spaces becomes empty. So such spaces are tracked down by this avail array. Okay, the avail array, avail array will take care of that. So that is about the garbage collection. So let us understand the garbage collection in detail. Suppose some memory space becomes reusable because a node is deleted. So whenever a node is deleted, memory space becomes reusable from a list, or or a or sometimes an entire list can be deleted from a program. That space should be used for a future use. To do this, the OS of a computer may periodically collect all the deleted space on the free storage list. So any technique which does this collection is called as a garbage collection. Any technique which does this is called as a garbage collection. So it runs through two steps. Okay, so one is nothing but computer runs through all lists, uh, tagging those cells which are currently in use. So this is that first case which you discussed. Okay, where information is there. This is the second case. Then computer runs through memory, collecting all untagged space, So that is the free space. Okay, on the free storage list. Because that is how the garbage collection is done. One is all free spaces it will take care. Okay, because we can delete that node from between also. That option is there. So that space becomes empty. That address becomes empty. So that address we should be able to use for some other list, or in that same list if you're adding again a node. Okay, you can use that address. Okay, because here addresses are not continuous in nature. You can store it anyhow. Okay, so that is why we need a garbage collection. Okay, next we'll go forward. Yes, now we have a separate concept called as overflow underflow. So students, sometimes new data you need to put, and if in the new data, okay, uh, new data you need to put, and in the data structure space is not there. Okay, so that is what they are telling. Sometimes a new data are to be inserted into a data structure, but there is no available space. That is, the free storage list is empty. Such situation is called as overflow. Notice underflow. Underflow is exactly opposite. That is nothing but, the term underflow refers to situation where one wants to delete the data from a data structure, but that is empty. Okay, so whenever a data structure is empty, see, that time how can you delete anything? You cannot delete anything. So such case is called as underflow. So we have already understood about the operations of the linked list. Now let us understand about the functions of the linked list. Here first, functions or operations you can tell. First is the creation. So this creation operation we will understand in this video. Now first let us understand you via a small algorithm. So student, how do you creation means what? How do you create a node? How do you create a node? So here for you will have to use various variables. One is normal variable also, one is node type variable also. This first is a node type variable. Okay, so whenever you first what you do is nothing but you initialize the first is equal to null. When you do this, a node type variable will be created, because first is a node type variable, but there will be nothing stored in it and it will be pointing nowhere, so that is why null is stored. Then you create a new node, okay, and that new node is called as temp, and this temp node is of type node, so that is why a node will be created. Then you fill its data field, so that which is the 10. Okay, so temp will again, temp will also not point anywhere, okay, but you will, it will have a data. Now you, what you do is nothing but you connect the temp, okay, to the first. So when you do that, temp's link field should be, will point to the first node. Okay, next what you do is nothing but you see temp is connected to first, so here you have inserted into the beginning, and but first node will always first name, that pointer will always point to the first node. So you need to first node, you need to put, make it point here. Okay, you need to make it point here. Okay, so that is what happens here. That time this existence will be gone. Okay, that time this existence will be gone. Now this is how you create a node. This is the first node creation. Now let us see how via code how first node is created. Only one node is created, and also how various other nodes are also created. In code we can get it better. This is the idea. Yes. So this is the creation code, students. Yes. So here what we are doing is nothing but we are using a function called as create. Okay, this is the create function. You can give any name, any function, and here first we are creating the type. Okay, temp. Okay, node type variable called as temp, and this is how you initialize node type variable. So this is a node type variable. Okay, creating or declaring a node type variable. Yes. Next, you need to insert a data into this node type variable. So that is done by using a scanf list. Okay. So this is nothing but inserting this. No, this is not exactly inserting. This is basically you are telling n will tell how many nodes to declare, how many nodes to how many nodes to uh, how many nodes to create, in a linked list. So initially you make first as null. Okay, so that time one node will be created called as first, and it will not have anything, it will not point anywhere, so it is nothing but null. Next what you do is nothing but, yes, see, you need to create many nodes, not one. So while n is not is equal to 0, that means what, till n becomes equal to 0 you have to go on creating the nodes. So let me take n as 2 in this case, so that you'll get a clear cut idea. So first I will create temp is equal to, this is a temp variable I am creating, which is equal to struct node star malloc size of struct node. So here memory allocation will be done. Memory allocation for temp variable will be done. So this temp variable is used only for creating a nodes. Okay, later on we change the names. Memory allocation for temp variable is done here. Okay, so when we do this, a variable called as temp will be created and a memory will be created for that. Okay, and a memory will be created for that. So here you write this, these all printfs are just for showing the commands, I mean doing just for showing what is happening in your slide. Okay, now in your whenever you are executing. Yes, so scanf percentages temp of data. Okay, so when you do this, temp of data field will be filled. Say let me want to fill 5 10, so I have filled it 10. Okay, don't confuse this is a null. Okay, so 10. So next what I do is nothing but temp of link is equal to first. Okay, so temp of link is equal to first. Here what I do is nothing but the temps link data field I have already filled using this one. So here I is filling the data field of temp. So next here what I do is nothing but connect temp to first. Connect temp to first. Yes. So this is a linked field, students. When I do this, okay, when I do this, yeah, the connection happens like this. Actually the connection happens like this, but instead of showing like this, okay, I'll show you in a simple manner. I'll connect this temp into first, so this will be gone here, will not have any existence, and first will come here. Okay, yes, and then later on what I do is nothing but I just change this temp first is into temp. Okay, so what will happen is nothing but this will be gone, this will be gone, and this will only become first. Okay, and the first node will be pointing nowhere now. Okay, now one node is created. Okay, even temp will be pointing at this stage, temp also will be pointing here, first also will be pointing here. Next what I do is n is minus minus. When I do n minus minus, say n as 2, no first n was 2, so n will become 1 now. Next same process again, I'll create a node, again I'll create a node called as temp. Yes, so now temp will change. Okay, it will change. Then I'll put some value into it. I'll put some value into it. Then I'll put 20. Next what I do, that is how do I put by temp of data. Then I do temp of link is equal to first. Yes, now see students, now this exactly this operation you can see, temp of link is equal to first. This is nothing but temp of link is equal to first. Okay, so which is nothing but connect temp to first. This is connect temp to first. Okay, so let me write it for you once again, so clear. Yes, connect temp to first. Yes, next I do first is equal to temp, so this name will be changed now here. So how do I do that? When I do this, because students we know that first will always be stored in the beginning, so when I do that, okay, first will be connected here, this will be first now, because here what happened here, creation and insert at the beginning, so this is also happening here. What is happening here? Here creation and insert at beginning is happening. Certain beginning. Okay, yes. Now again, once again, temp also will be here only. Temp also will be here only. Now when you create a new node, it will change. Okay, but we are not bothered about temp. We need only first. Remember, first is always created to the first is always there in the beginning of the list. So this is how you create a linked list. Now this code to insert to the front, students, this is always, you see, this is again having the same set of code which we studied in the creation. Same set of code understood in the creation. Same set of code present in creation. So of course, so first line is for memory allocation for temp. So here just to display, enter the data to be displayed. Here data insertion, and here whenever you are connecting the temps link into first, okay, then you are making temp as first. Okay, so these are the 5 steps insert at the beginning. Okay, this is a function name, and this is a temp type initial declaration of the temp type variable. Okay, that is inserting at the front. Now let us see inserting at the end. Now let us see inserting at the end. So whenever we insert at the end, of course, yeah, we'll have one we are having one link list here. Okay, we are having one link list here. Okay, so that is, yeah, so it is having two data, 20 and 10, and first is pointing to the beginning. Okay, at the beginning of the linked list. And here we need to take one more variable called as t, because this variable is used for traversal, in another words, moving through the list. It's also used for moving through the list. And when this t reaches the end, when this t reaches the end, we need to connect this t to temp. So what we do is nothing but we use t, we create t, okay, and start moving it. In the meanwhile, we also have to create a new node called as temp. So we know that all new node we create in the name of temp only. Then we need to connect this t link. Okay, say when we move, t will come here. Okay, t, yeah, as shown here. Then we need to connect this t's link into the temp. Okay, when we do that, this node will be created. So let us understand that concept using in the code which is given in the next slide. Okay, so this is the code to insert at the end. So we need to create two variable. Temp we are using for yes, new node creation, and t we are using for traversal in the list. Then this temp memory allocation, and this one just for display message in screen, that is enter the data to be inserted, display in screen. And this one is data insertion into new node, yes. So first one, now what we are doing is nothing but we are making t is pointing to first. So students, say you have a list this way. Okay, we have a list this way. It already has some value, say 20, okay, 10, and now I need to insert here. So first is pointing here, now t is also pointing here. Now both are pointing to the same node. When you do this, t is equal to first, so make t point to first node. Next, when if first is not is equal to null. So students, this is the case. If first is not is equal to null, that means what, students? This case, whatever I am showing now. Okay, if first is not is equal to null, what you are supposed to do is you need to insert inside while t of link not is equal to null. So while t of link not is equal to null means what? Traverse till t reaches last node. Okay, and what is this? First is not is equal to null means what? First is not it will be null, it will be null if only one element is there, if only one element or one node, okay, element or node, only one node is there. Okay, what you need to do is t is equal to t of link, so move t, move t. Okay, so what you need to do this. Okay, next what you're doing, t of link is equal to temp. Okay, so students, you can see here we don't have any brackets here, we don't have brackets, so these two steps will be executing. Okay, these two steps will be executing, that is while t arrow link not is equal to null, t is equal to t of link, move t till end, move t till end of list. Okay, so when I do this, t is equal to t of link, t which was here will move here now. Okay, so in this list, we have only two nodes, so in this case only, this case this will become false now. Okay, that is t of link will become equal to null in this case. Okay, so here t of link will become equal to null. So that time what we have to do is nothing but we need to do this step, that is t of link is equal to temp. Okay, t of link is equal to temp. So temp was created earlier, students, we have already seen in that algorithmic part. So what we do is t of link is equal to null. Okay, so this was temp, say some value you had put for that 40. Okay, that was seen in the previous slide. Okay, then what you do, that is how you create. So this is nothing but, in this stage you are doing t of link is equal to m. Okay, this is the normal case, this is the normal case how we insert at the end. This is how insertion happens. So students, next case is nothing but if first is equal to null. Okay, then what happens, only this will execute. If first is equal to null, if first is equal to null, then what you do is, you whatever temp is there available here. Okay, okay, say only one node, only one node is there. Okay, then what you do is nothing but whatever whatever temp is there. Okay, whatever temp is there, whatever temp is there, that to itself you make it as first temp, also that itself you make it as first. Okay, so only one node case, so this one is one node, only one node, only one node. So this is how insertion at the end works. Okay, this is how insertion at the end works. Thank you, students.